Hello guys and welcome back. So now we're going to add another feature to the curves, and we're going to have them, instead of attracting to a single point, we're going to have them attract to a different geometry. And in this case I'm going to use a simple grid, and we can use any object we want. We can copy the same object as well and link the two if we wanted to, or have any kind of special geometry that you want to create cool connections in between. That also works. So I pasted in a curve from the previous scene, and all we have to do is we need to, right now we're taking these points and we're moving them to the 0, 0, 0, and the way we're connecting them is using this ID number. So as long as we have a point ID that matches between the two, we should be able to connect whatever geometry we have. So I'm going to clone this action, create a reference copy. That way whatever I change here, it's going to change on the grid as well. Okay, so we have the same number of points. I'm going to copy this and give them the same ID as well. It's not going to be the same because the point layout is different. And then I'm going to connect this instead. If we now take a look, we have connection between X geometry and this. If I copy this, let's transform it here and maybe scale it, something like that. We can use it instead. So let's scatter points on that guy. Let's mix them. Add node. Now we're connecting these two guys. And this will work if we take a look. We're still using the old system that's going to connect them to the center. So we're fixing that, but we can connect whatever geometry we want. For now I'm going to use the grid, and I want to have the curves transition at the beginning using that interesting method, using the normals, and then blend into this shape. So I'm going to do this for one of the curves. Let me set this back to 1. So we have one curve, and let's copy this, make sure we have the latest one. I'm going to disconnect these guys, move them away, and then instead of it blending to that circle, I don't want that anymore. I just want the blend between the original position and this. The only part I'm interested in is this bit. The circular one is just, I want to show you guys something to use the cosine and sine for. So we have the curves going in and then transforming, reaching that goal. But once we run this, let's copy it here. Let me delete all these. And let's change the point count to 1,000. Let's do 100 to start with. Okay, so we're good. We have curves going that way, reaching this guy. What I want to do is I want to add interesting details here. I don't want them to go straight. So I want to add some noise that moves these curves and make them swirl, basically. So let's dive inside, or copy this. And I want to use the result here with something new. So I'm going to, what I need to do is I want to shift these points in a wavy manner. I want them to go like that in the X direction and the Z direction as well. So I want them to do this motion, and maybe in the Y axis, any axis we want, really. Not in the Z, not in the X, because the X is aligned to this. So the Z and the Y information. Okay, so I'm going to use a texture node, and this is, again, we could have done this, but I wanted to show you how to use the point number and compute the linear value in SOPs. We can use a texture node and set it to arc length, and this will generate a curve, a UV coordinate that we can use the U coordinate to get the ramp, which we've done last week. Okay, so let's dive inside, and I don't need this. Actually, I just need this part here, and I don't need this anymore. So I'm going to, you know what, I'm going to not reuse anything. I'm going to create something new. So point vault. Let's dive inside. Vector to float. I need the U coordinate. Let's connect that to the color. Cool, we have that. And I want to use this to generate a sine and cosine function. So I'm going to use a sine function. Okay, I'm going to add this to the y position of the points. So let's do a vector to float. We're going to get the y coordinate. I'm going to add this sine function to it. I'm going to use the float to vector. Okay, and let's increase the input. Let's multiply this. Let's multiply by a constant. Let's increase this, and as soon as we start increasing it, you can see we're getting this nice swirly motion. Now I'm not sure why this curve is short. Looks like we don't have the same number of points. 1,000 there. $100 here. Sorry, this this only works with a for each, so we need to set this to 1. Sorry about that. Okay, let's continue. So now we're adding a this shape, this motion, to the y position. I'm gonna create a cosine function and add this to the z to the x coordinate. So add x coordinate, cosine, and connect this to the x. And right now we're getting this circular shape. The reason for that is because we're using the same input for both sine and cosine. We need to add we need to introduce an offset between both of them. So I'm going to use an add node or add constant and add an offset here. Just one is fine. I'm going to copy this, and now we can shift the x the sine and cosine function. Okay, let's take a look at the original result and this. Cool. So right now we're changing the x and y position of the points, but this is not very interesting because it's very linear, and if the curve is going like this or it has a different motion, then the x and y is not going to work. What we need to do is we need to compute the tangent and a vector that travels along the curve, and then use the cross product to find a vector perpendicular to that pointing in the y direction, and then another one pointing in the x direction. So let's use a polyframe. I know I'm not going to need the normals again, so I'm going to just override that. And if we take a look at the normals, we have a vector traveling along the curve. Cool. So let's dive inside. I don't need to change the position. I'm going to compute the cross product of the normals with an up vector, and let's take a look at that. And now we have this very interesting vector. See, it's pointing in a more interesting way. And then if we copy this and compute the cross product between this and the n again, the normals again, we're going to get another interesting vector that points upward. I'm going to use these two to push along the curves. So this first one I'm going to multiply by the x. Let me first normalize it. This first guy I'm going to multiply by the sine function, and let me delete all this. Okay, let's do this. Okay, so we have this vector. I'm going to normalize it and then multiply it by the sine function, and I'm going to add this to the point position. So I want to offset the points using along this vector after multiplying it with the sine function. So let's take a look at this result, and look at that. Now we're getting something much has a much nicer flow. If we go up to this curve, for example, and let's select a point, hit tab and type in soft transform. I'm going to move this down and let me increase the radius. I want to change this completely. So if we take a look now at the result, see it's respecting the flow instead of just a random y vector. So I'm going to do this similar thing using the cosine and with this with the cross product of this result. So let's move this up maybe. Hopefully that will make it easier. And let's add a multiply. Let's make sure we normalize the result. Let's multiply this by the cosine function, and let's add this as well. And now we're getting this swirly motion. Let's disable this, and now we're getting a spiral shape. We could have used this system as well for the week 2 to create the spiral, but I wanted to show you guys something new. So okay, let's delete these two guys. I'm gonna add a multiply here. I'm gonna expose it and call this cosine mult. I want to have 2 multipliers for each one of them, and then I'm gonna call this multiply by cosine, so I can have different repetition for each one of them. Sine, sorry, multiply. Let's go up, set this to 10. The higher the value, the more squiggly the curve is going to be. And then as soon as we start introducing this, we can get some cool shapes. Now if we keep them in sync, we get a spiral. So let's copy this, paste relative reference here, and increase this, and get spiral. Cool. Let's set this to 20. One last thing I want to add is I want to vary this result. Let's do this on all the curves. So I'm going to copy it here because we don't have to because we don't need to loop over each curve. We have the UV coordinate, which we're the only thing that we're using. We don't have to use a for each for this example. I'm going to set this to 1000. Okay. Take a look. These guys, I'm going to turn off the soft transform, and now we have the squiggly curves. Let's set this to 60, and I'm going to use a color primitive random from random per primitive, and that will give us different color per curve, so it's much easier to see. The only thing I want to change is I want to introduce an offset to each curve so that the result is randomized. And I'm going to use the primitive number. This is again the primitive number. I'm going to use a random function, primitive number, and then I'm going to add this here. Add this to the sine function. Okay. and I'm going to copy it. I'm going to add a constant to change the seed of the normals of the randomization. And I'm going to use this as an offset to the input for the cosine function. Let's add this here, and now they're not overlapped anymore. Okay. Now one last thing I want to do is I want to be able to control the amount of this. So I'm going to expose this and call this amount sine. And here, actually this is amount cosine. And this guy is the amount of the sine function. Okay, let's change this, set this to 1, this to... Why is it doing this? Oh, sorry, the multiply should not be a global to the vectors, it should only be to this result. So I'm going to disconnect it here, add a multiply. Don't think so. Yeah, it's the same. Okay, I'll check this later. It shouldn't be stretching like that. Shouldn't be stretching like that. I know why. We shouldn't be adding, we shouldn't be multiplying these two. We should be adding them. So let's add this, and then this as well should not be a multiply. This should be a multiply, that's fine. I know, I'm confused. This could be a multiply, yeah. Let's try and add. Yeah, definitely a multiply, not an add. Okay, I'll check the scene. I don't know why it's confusing now. Let's go back. Okay, so we'll leave it like this. And the last thing I want to do is I want to fade this result. I don't want to affect the curve for its entire length. So I'm going to create a rest attribute, and this node stores the current position into a rest attribute, and then here going to create a new point fop, dive inside, and then import the rest attribute using a bind node. And then we need the u coordinate, so vector to float, and then I'm going to mix between the rest attribute and the position, the newly deformed position. So if I change this to 0, we get the original curves. If we set this to 0, we get the deformed curves. And we're going to multiply, we're going to use a ramp with the u information, so we can change it along the curve length. Interpolation, okay, let's go up. And now you can see it's on here, and then it's getting back to its original shape. So we can do something like this. And here I'm going to set it to 1. So it restores the original shape. And let's set this to black. So it's only happening in the center. Okay, so we're deforming the center only. And then we're keeping the beginning and end to be the same. I can also lower this to 0.5, 0.5, 0.5. We're getting 50% only of those curves. Okay, I think that's pretty much it for this video. I'm going to double check this operation. The idea is we have a vector that travels along the curve. We compute the cross product, so it's this way, and then the sine function will return -1 and 1. So it will either push along this direction, or it will flip it and push along this direction. And I'm not sure why this is confusing now. Yeah, I think a multiply is fine. We'll go with the multiply. It's fine for now. Cool. So the beginning is working. The last bit is working. We're adding randomization here. And in the center, I think it's too much, so let's set it to 20. Less repetitions. And then the last bit is we want to find the curves that are intersecting with the geometry and remove those. We want to only keep the curves that don't intersect with the geometry. So we're going to do that in the next video. Thank you guys for watching, and see you in a bit.